Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about principles of UV visible spectroscopy. So let us start learning of the mystery behind the UV visible spectroscopy. You should know these important parameters. The UV radiation region extends from 10 nanometer to 400 nanometer, and the visible radiation regions extend from 400 nanometer to 800 nanometer. You also know about near UV regions, 200 nanometer to 400 nanometers. Far UV regions below 200 nanometers. Far UV spectroscopy is studied under vacuum conditions. The common solvent used for preparing sample to be analyzed is either ethyl alcohol or hexane and other solvents. So, you know the electronics transitions like sigma star transition, pi to pi star transition, n to pi star transition, n to sigma star transition. So, these are many transitions. If you look at n to pi star transition, pi to pi star transition, n to sigma star transition, pi to sigma star transition, sigma to pi star transition, sigma to sigma star transition. So the possible electronic transitions can graphically shown here. But we are always interested in few transitions like pi to pi star and n to pi star transitions. So first sigma star transition, pi to pi star transition, n to sigma star transitions, n to pi star transition, sigma to pi star transition, pi to sigma star transition. Now sigma to sigma star transition. Sigma electron from orbitals is excited to corresponding antibonding orbital sigma star. The energy required is large for these transitions. Methane has CH bond only and can undergo sigma star transition and shows absorption maximum at 125 nanometer. Now pi to pi star transition. Pi electron in bonding orbital is excited to corresponding antibonding orbital, pi star. Compound containing multiple bonds like alkene, alkyne, carbonyl, nitriles, aromatic compound TC undergo pi to pi star transition. Alkenes generally absorb in the regions 172 to 205 nanometer. N to sigma star transition. Saturated compounds containing atom with lone pair of electrons like oxygen, nitrogen, sulfur and halogens are capable of into sigma star transitions. This transition usually require less energy than sigma star transition. The number of organic function groups which n to sigma star peak in UV region is small. A small means 150 to 250 nanometer. N to pi star transition, an electron from non-bonding orbital is promoted to antibonding pi star orbital. My friend, you know compound containing double bond involving heteroatoms like CO, carbon, triple bond nitrogen, nitrogen, triple bond oxygens undergo such transition. N to pi star transition required minimum energy and shows absorption at longer wavelength around 300 nanometer. Now, sigma to pi star transition or pi to sigma star transition, these electronic transitions are forbidden transition and are only the theoretically possible. N to pi star and pi to pi star electronic transitions show absorption in regions above 200 nanometer, which is accessible to UV visible spectrophotometers. The UV spectrum is of only a few mode of absorptions. So, you should also know the term used in UV visible spectroscopy. Chromophore. This is very important for exam purpose. What is the chromophore? The part of a molecule responsible for imparting color are called as chromophore, or the function group containing multiple bonds capable of absorbing radiations above 200 nanometer due to N to pi star into pi to pi star transition. For example, Na2, NO, CO, carbon triple bond, double bond nitrogen, triple bond nitrogen, carbon carbon double bond to sulfur. To interpret UV visible spectrum, following points should be noted. Non-conjugated alkenes show an intense absorption below 200 nanometer, are therefore inaccessible to UV spectrophotometer. Non-conjugated carbonyl groups compound give a weak absorption band in the 200 to 300 nanometer regions. So, chromophore acetone, which has lambda max 279 nanometer, and that cyclohexane has lambda max 291 nanometer. When the double bonds are conjugated in a compound, lambda max is shifted to longer wavelength. 1,5-hexadiene has lambda max 178 nanometer. 2,4-hexadiene has lambda max 227 nanometers. You can see the examples here. So, conjugation of carbon-carbon double bond and carbonyl groups shift the lambda max of both groups to longer wavelength. Ethylene has lambda max 170 nanometer, acetone has lambda max 279 nanometer, crotonaldehyde lambda max 290 nanometer. Now the auxochrome. What is auxochrome? The function group attached to a chromophore which modifies the ability of the chromophore to absorb light, altering the wavelength or intensity of absorptions. The function group with non-bonding electrons that does not absorb radiation in near UV regions, but when attached to a chromophore alter the wavelength and intensity of absorptions. You can see benzene lambda max 255 nanometer, phenol lambda max 270 nanometer, aniline lambda max 280 nanometer. Aniline lambda max 208 nanometer. Now option and intensity shift. Batochromic shift, red shift, hypochromic shift, blue shift, hyperchromic effect and hypochromic effect. What is the batochromic shift? You know, when absorption maximum lambda max of a compound shift to longer wavelength, it is known as batochromic shift or red shift. The effect is due to presence of an auxochrome or by the change of solvent. An auxochrome group like OH, OCH3 causes absorption of compound at longer wavelength. In alkaline medium, paranitrophenol shows red shift because the negatively charged oxygen delocalizes more effectively than the unshared pair of electrons. So paranitrophenol lambda max 255 nanometer, lambda max 265 nanometer. When the absorption maxima lambda max of a compound shift to shorter wavelength, it is known as hypochromic shift or blue shift. The effect is due to presence of an group causes removal of conjugation or by the change of solvent. You know, aniline shows blue shift in acidic medium. It loses conjugations. Aniline lambda max 280 nanometer. In acidic condition, it is forming anilinium chloride lambda max 265 nanometer. Now, hyperchromic shift or effect. When absorption intensity lambda epsilon of a compound is increased, it is known as hyperchromic shift. If auxochrome introduces to the compound, the intensity of absorption increases. You know, pyridine 257 nanometer and 2-methylpyridine lambda max 260 nanometer. When absorption intensity epsilon of a compound is decreased, it is known as hypochromic shift. Naphthalene, you know, epsilon value 19,000 and 2-methylnaphthalene 10,250 nanometer, 50 epsilon. Now you can see in demonstration shift and effect: hyperchromic shift, hypochromic shift, red shift and blue shift. Now, application of UV visible spectroscopy. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.